Hi, in this video we're going to have a look at this Cambridge Audio Amplifier. So this is a Cambridge Audio A4 integrated amplifier which was about to get thrown out, and I thought I'd rescue it for use in the lab here. So I've got a couple of Bowers & Wilkins bookshelf speakers up on the shelves up here, and until now I've been driving those with the Iec micro system, but the amplifier in that isn't very powerful. So I have been out looking for a replacement amplifier for that, but then this one came along, so I thought I'd rescue this and use this one here. So it's quite old, and I'm expecting to have to replace the electrolytic capacitors in here, so I've already purchased a whole load of capacitors, as I do want this to last another 10 years or so, so we may as well replace all of those and make it as good as new. And then I've got a modification which I'd like to do to the front panel, so we'll have a closer look at the front panel and I'll show you my plans. So here we have the amplifier, and on the left here we've got the power button and power LED. We've got a couple of knobs here for bass and treble tone controls, and also a button to bypass these. Then we've got the volume knob, balance knob, and then the input selector switch, and then finally a button here which allows you to monitor the output to the tape or mini disc. And what I'd like to do is make the area around these knobs light up so that you can see the knobs at night, and maybe also make the little indicator on the volume knob light up as well. So what I've done is I've already measured up and got some acrylic cut, and the idea is that there's some notches in the acrylic here which we can sit some LEDs in, and then I'll take off the front panel and glue these to the actual front panel. And this is clear acrylic, it's still got the protective coating on at the moment, but with the LEDs sat in there, you should get a glow on the inside edge of this ring, and with these glued on the inside you should just be able to see a glow around the knob. So we'll take the unit apart, we'll do a quick teardown, as I'm going to replace all the capacitors anyway. Most of the boards are going to need to come out, so we'll have a look at all of the boards and have a look at the construction, because this is supposed to be quite a good amplifier. Cambridge Audio are generally a reasonably respected brand in terms of hi-fi equipment, so we'll have a look inside and see how it compared to the cheapo amplifier that we looked at a few weeks ago, and then we'll start with the modifications of putting these bits of acrylic and LEDs for the front panel. So here we have the inside of the amplifier, and you can see this is a really conventional stereo amplifier, so there's no digital circuitry in here at all. This is a straight hi-fi amplifier for driving two speakers. On the left here we've got the power transformer, the mains inlet, we've got the power amplifier board here. On the right here we've got the input selector and the preamplifier stage, and then at the bottom left here we've got the power switch, and then we've got the volume and tone control. So really straightforward and supposed to be quite high quality. So let's have a closer look at each of the components. So here we have the Iec Inlet, so it's nice to see a inlet connector on an amplifier, because often the cable is fixed, which makes it quite a faff sometimes to feed cables through. So we've got an Iec connector with a bit of Loctite on each of the nuts. We've got the earth cable going straight to the chassis, and that's also Loctited in. And then we've got the power transformer here. So this is a custom wound transformer, there's no markings on it whatsoever. It says audio grade transformer. I think this is just a standard transformer, possibly with some shielding between the primary and secondary, but I can't find any information on this, so I don't know. But we've got a centre tapped secondary here, which goes straight into the power amplifier board, and then we've just got the 240 volt primary, and then this goes to the front panel PCB. So here we have the front panel power switch, and we've got the power coming in on this 2-core flex from the Iec connector at the back, and then we've got a proper switch here with a capacitor across the switch terminals, and then we've got a glass fuse in a fuse holder with a plastic cover. And then I'm not sure if you can make out here, but there's a couple of links here. One of these says 230 volts and one says 115 volts. There is an extra terminal just here, so possibly this amplifier is available with a centre tapped primary as well, and all they're doing is either selecting the 230 volt or the centre tap 110 volt winding here, but this I don't think it applies to this because we've only got a single primary on here. So here we have the power amplifier board, and down at the bottom here we've got a bridge rectifier consisting of 4 diodes here with some snubber capacitors which you can just about see between those diodes, so those little yellow capacitors here. We've also got a couple of fusers on the secondary of the transformer, and then we've got the big bulk storage capacitors. So these capacitors are 220 microfarads at 50 volts, and there's 8 of those. And then if we move up the PCB, we've got the power transistors. So these are matching pairs, so SAP 15s, and this is the N type and this is the P type. And these are Darlington transistors, and they've also got built-in temperature compensation diodes and emitter resistors, but these are a real pain to get hold of if they ever blow. So the first thing I did when I got this amplifier was check that the outputs worked properly, because if these were faulty, they usually go for about £20 each. So once you need to replace one of these, it's starting to get quite expensive quite quickly. But the idea is that these are temperature compensated, so both the left and the right channels are matched over temperature. But they're reasonably good. I think these ones are 15 amp outputs, the SAP 15. And they've got a built-in emitter resistor of 0.22 ohms, and the gain of these is between 5,000 and 20,000, so reasonably high gain. The amplifier on this board looks a little bit small, and I believe that a complaint of this Cambridge Audio amplifier is that the heatsink wasn't all that sufficient, and the bias through these transistors at quiescent was quite high already, and these can overheat and get damaged. So we'll check the quiescent current through the transistors when we power the device on later on. But it may be worth at some point upgrading this heatsink if it starts to get a bit warm. And then here we have the actual amplifier stage here. So this is a Class AB amplifier, so nothing too surprising here. We've got a trimmer capacitor here for setting the bias current through the transistors. We've got a few little electrolytics all over the place, some transistors which do the amplifier and feedback stages. We've got a red LED here, and this is often used for setting the current through the 2 input transistors. So you develop a voltage across the base emitter of the transistor that's connected to the input transistor pair, and because the red LED kind of has a higher voltage than the forward voltage than a standard diode, it becomes quite a convenient way of getting a slightly higher voltage across that base emitter junction. And the left or right channel, they're both fairly identical, so I think they're basically a mirror image of each other. And then if we have a look at the back of the power amplifier board, so we've got the back of the large bulk capacitors here, and you can see we've got a couple of regulators here. So I think these are 7815s and 7915s, and these are just for the op amps that are around the amplifier. So the front panel PCB has a couple of op amps for the volume and tone control, and then the input selector PCB has one on the preamp. But you can see the amplifier board is really quite a mess. It's not very clean at all. Probably if they tidied it up, it wouldn't have any effect on the sound quality or anything like that, but it is quite untidy. It doesn't look very good. You can also see we've got a couple of air cord inductors here for a bit of stability. We've got the wires which go to the speaker connectors are just soldered in straight from the outputs here of these transistors. The wires aren't massively thick, but probably thick enough. And then we've got some wires here which are presumably the regulated supplies going to the front panel board. And then we've got the left and right channels coming in here in some shielded cables. And then you can see the back of the heatsink. So they have put some fins on the back of this heatsink with some vents in the bottom of the amplifier case. So potentially I was reading about an earlier revision of this amplifier, because this is the revision 4. But the heatsink fins are still pretty flimsy. It doesn't look like it could dissipate that much power before this slab of aluminium starts getting pretty warm. So we'll have a look at the temperatures with them driving the speakers just to see if it's worth adding any extra cooling in here. But at the bottom here, so we've got the front panel here for orientation, but we've got the board here, which is the input selector, but there really isn't anything on here. So there's a load of optional components just here which aren't fitted. We've got the unity gain output buffer here, so this will be going to the tape and mini disc outputs for recording, and then there's an optional module here with some pins sticking up for the phono stage, so that's just to increase the level of the phono input back up to line level. But they've just kind of put a huge PCB in here which isn't really needed, but it does kind of make it look quite nice. But they could have just chopped the PCB here basically and just had the input selector switch on the front panel board here instead of having this break here. But there doesn't seem to be any active circuitry here, so I'm assuming the inputs just go straight to this input selector switch, which is just a rotary switch, and probably just switching these directly. The potential downside of that is that if the mechanical contacts are actually switching the audio, if this switch starts to get a bit of crud on the contacts, you will start to hear a bit of crackling when you change the source, or possibly it may degrade the audio signal when it's already on a selected source. So it might be worth giving that a quick squirt with some contact cleaner, because it has got a bit of dust in here and it may have made its way into the contacts. And then here we have the front panel PCB, so we've got the volume knob here and a bit of circuitry here with an op amp in the middle. So this is probably just a buffer with the volume control in the middle of it, so that the input which has been selected by the input selector switch is buffered before going into the amplifier stage. And then we've got the tone controls here and the associated op amp here for adjusting the bass and treble control. So there's not really anything complex in this amplifier. That's basically all of the circuitry here. So I'll start taking apart the front panel and everything, and we'll have a look at how we're going to modify the front panel. So I've taken off the front panel, and this is a piece of brushed aluminium which has been painted black. It's quite substantial, it's about 3mm thick. And then we've got another piece of thin, it feels like steel, which is what all of the various knobs are attached to, and it's recessed by about 2 or 3mm from the front panel. So what I've done is I've cut some acrylic in both 2 and 3mm thicknesses, and the idea is that I'm going to glue these to the inside of the front panel here, and we'll glue some LEDs around in the little notches. So I've cut these out for all of the various knobs that are on the front here, and once I've wired up all of these LEDs point to point, we should get a nice glow around each of the holes where the knobs are. And then potentially I might be able to push this little marker out from the volume knob and put an LED in there instead, so you can see the position of the volume knob when it's dark in the room. So I bought some LEDs. These are yellow LEDs, 589 nanometers. So I didn't want to go for blue or anything like that, which would be quite distracting. So this should give a nice glow around each of the knobs. And I'm just going to glue these in these places and then wire them up point to point, and then power them probably straight off the transformer rather than the voltage regulators, which are on the power amplifier PCB. So to start with, I'll just measure whether we need to use the 2 or 3mm pieces of acrylic. Ideally it wants to be closer to 3mm because the LEDs are 3mm, so there's a good chance that I may have to sand down each of these LEDs to fit between the front panel and this piece of steel here. So I'll have a look at that, and then I'll glue these in place, and then we'll start wiring them up, and then we'll take all the boards out and replace the capacitors. Right, so I've taken the amplifier apart. The boards are attached with soldered connections in some places, so I'm going to leave everything joined together so like the transformer's permanently joined to the power amplifier board, but I'm going to start with the power amplifier board and just replace all of the capacitors on there, so just a blanket replacement, just so I know that it's going to work well for another 10 years or something like that. So I'll start desoldering the capacitors and then start replacing them with the new ones. Okay, so I've got most of the electrolytic capacitors out of the power amplifier board. So I've got a whole pile of them. I've got a few more here. The brand of these is RM, whatever that is, and that's on all of these capacitors. But one thing I did notice is these are really quite light. They don't feel very heavy at all in comparison to the Rubycons which I'm replacing them with. So there's definitely a weight difference. It might be worth just having a look at the ESR of these, although they're probably absolutely fine. So when I connected the speakers to the amplifier, just to test it, there was no mains hum or anything like that, which is usually a telltale sign that these capacitors have started to dry out, but they possibly are on their way out. I'll just grab the ESR meter. And actually the ESR is at 0, so that's really really good actually. Capacitance 2553. But 0 ESR, below what the meter can read anyway. I'll just try another one. And 0.01. So actually these are perfectly within spec, but it's worth just changing them. I do want this amplifier to last a while, so I'll carry on with the replacement, but the capacitors are out, so I'll start replacing them with the new ones. Okay, so that's all of the capacitors replaced on the power amplifier board, so now I can move on to the remaining 2 PCBs. Okay, so that's all of the capacitors replaced, and I've just had a quick look at what they've done with the transformer primary here, and it's basically as I expected. So in the 110 volt countries, it looks like they have a center tapped transformer, and all that this link does is either join the incoming main supply to the center tap or the outside tap. So in 110 volt territory, the upper tap of the transformer is just left disconnected. So we can assemble all of this back together again now, and then we'll turn it on and just find out what voltage the transformer output is, because when we connect up the LEDs on the front panel, I kind of need to know what forward voltage for the LED string that we want to aim at. So I'll assemble all of this back together, and then I'll rejoin you at that point. Right, so I've assembled the amplifier back together again and connected up all the wires. I've got it plugged into the mains, and I've got a pair of speakers connected to the speaker outputs. So I should be able to turn the amplifier on. And I've got my phone connected to one of the inputs, so I think I've got the input selector on the right input. So we should just be able to turn up the volume. And that seems to work okay. Let's check the balance. So the balance control works properly. And the tone controls are also working properly. So that seems to be working correctly as it was before. And then just before I put the power amplifier board in, I connected a few wires to the rectified DC from those capacitors. So we've got ground in the middle, and then I think that's the positive and the negative voltages. So we can have a look to see what voltage the rectified DC is at, because I need to know how many LEDs to put in a series string so that we're not wasting loads of power. So if I measure between ground and the positive, So we've got 43 volts and yeah, minus 43 volts. So we've either got a 43 volt output, or if we use it across the entire transformer, that's about 90 volts. So we've got 26 LEDs which I'm going to put on the front panel. So 26, there's probably too many to do in one big series string, so I think I'll have to split it into two. So 2 strings of 13 LEDs with a forward voltage of around 2.4 volts. That'll be 30 volts, forward voltage across each string of LEDs. So we'll do a few calculations in a moment just to see what kind of resistor we need, but I think 2 strings of 13 LEDs should be good enough. Right, so what I think I'm going to do is we've got 26 LEDs to illuminate to make the front panel light up. So we're going to have 2 series strings of 13 LEDs with a resistor in series. And to keep the load on the transformer balanced, I'll connect one of those series strings of LEDs and a resistor between the plus 43 volt rail and ground, and then the same again between ground and minus 43 volts. So I've got an LED here, which is one of the ones that I'm planning on using, set to 12 milliamps on the bench power supply. So we can measure the forward voltage of the LED at this particular current, and that's 1.978 volts. So we'll say the forward voltage of one LED is 2 volts, and if we've got 13 of those, the total forward voltage of this part of the string is 26 volts. So we need to drop 43 minus 26 volts in our resistor, which is 17 volts. So we need a resistor which has a value of 17 divided by 12 milliamps, which is 1.41k. And then the power dissipated in that resistor is 12 milliamps squared times 1.4k, which is about 200 milliwatts. So that's slightly high to dissipate in just one resistor, unless I can find a higher powered resistor. So probably what I'll do is I'll construct our 1.4k resistor from 2 or 3 resistors in series, just to spread the power dissipation slightly. But so now we can get the front panel, which hopefully the bits of acrylic have glued properly now, and then we can glue the LEDs in and wire them all up, and then just connect them up to the plus or minus 43 volt supply. Right, so the bits of acrylic seem to be glued quite well onto the front panel. So what I'm planning on doing is probably just hot gluing these LEDs into the slots all the way around. And I'll just do that so that we've got 2 series strings of 13, and we should just be able to wire them up point to point. And then when the LEDs are lit up, we should get a nice bit of illumination around the circles. Unfortunately, I forgot about the little ridge that's at the bottom of the LED. So it does look like I'm going to have to sand the LEDs slightly, just so that that bit doesn't stick up and stop the front panel sitting flush to the front of the amplifier. So I'll probably just run the Dremel across the little ridge that's around the bottom of the LED on all of these, and then I'll glue them in place, and then we can wire them up. So what I've done so far is I've just sanded the top of the LED so that it diffuses the light output slightly, and I've also sanded the 2 edges of the LED so that it's 3mm from top to bottom rather than the almost 4mm that it was before. And then I've laid down some Kapton tape. It looks a bit of a mess. I should have put the tape down before I glued down these bits of acrylic actually. But I'm putting the LEDs in and then just using some hot glue just to hold the LEDs in place. So I'll glue them all in place. I may end up soldering them as I go, because then I can glue the legs in place as well. Right, so I've soldered up all of the LEDs and they're glued in place. We've got capped on tape actually on the aluminium front panel to stop the LEDs ever shorting out on the aluminium. So it does look a little bit of a mess, but it's about as good as I could do. And we've got the LEDs here at 12 milliamps, so if I dim down the lights, it gives really quite a nice effect around the holes where the knobs are going to go in, so that's going to look quite nice when it's sitting there on the bench when I'm just working normally without all of the lab lights on, so I'm quite happy with that. The only thing which I need to do now is see if I can get this pointer on the volume knob illuminated. So there's a bit of plastic in here which I may be able to push out and then possibly push in a bit of fibre optic. I think I've got something similar to that size, and then sit an LED in there and just wind the wire around the shaft of the volume knob so it doesn't get fatigued too much when you adjust the volume, and just have that lit up so you can see the marker as you change the volume. But that should look quite nice once it's all in place. Right, so I managed to get the piece of blue plastic out from the volume knob, and all I've done is I put a bit of capped on tape over the hole and then filled it with hot glue and put the LED in there, and the hot glue managed to fill the hole so it's flush with the surface, and we've got a nice illuminated knob now. So what I'm going to do is I'm just going to reassemble all of the amplifier. I'll put the resistors in for the LEDs, so I think what I'm going to do is have 3 resistors in series and then heat shrink them and connect them up to the supply rails, and then for this there'll be another resistor just to limit the current to this single LED. So I'll assemble it all back together and then we can have a look at the finished product. Right, so I've finished putting the amplifier back together again, and now I've powered it up, and you can see we've got a really nice effect on the front panel of the amplifier. So we've got a nice glow around all of the knobs, and we've got the illuminated marker on the volume control so you can see the volume level, and in a room that's quite subduedly lit this is going to look really nice. So I'm going to put this probably underneath the oscilloscope and the power meter here, and replace the Iec micro amplifier which I've got underneath the desk. I didn't get a chance to measure the temperature of the heatsink, so I'm going to keep an eye on that and see whether it reaches excessive temperatures and see whether I need to add any additional cooling. But with the capacitors replaced, we should have this unit up and running for quite a few more years, so I'm quite happy with that. And I'm really looking forward to seeing how it looks in a room without some of these lights on. In terms of the other projects that I've got going on, so the LED controller, the GPS disciplined oscillator, the final modifications to the clock, and also we've got the Variac still to do. So I've got PCBs on order for those now, so it's been a bit quiet for a couple of weeks because I've been working on the PCBs and trying to get those done. The first batch of PCBs, so the batch of PCBs for the constant current LED drivers, have been shipped this morning, so I should be receiving those in, I think they said 3 to 5 days. So as soon as they're in, we're going to do another video. We'll assemble the PCBs and test out the constant current LED drivers, and we'll expand on the previous video, so we'll be driving 4 LEDs, and it's going to have the RS485 interface, and also we're going to work on the 2.4 GHz MyWi protocol to try and get that working. So I hope you enjoyed this video, and if you don't want to miss out on more, please subscribe, don't forget to give a thumbs up, comments down below, and thanks for watching.